Page 1 is just again a reminder of the standard form with center 0, 0, and standard form with a shifted one with center HK. And here I've split up the simple one as the negative square root and the plus square root. So there's a lower half and the upper half of the one with center the origin. I've repeated this example, but let us just fill in what is the domain here. In this case, our domain is from -3 to +3, and our range is from 0 to 3. We have a radius of 3 because this is the distance there, distance there, distance there, 3, 3, 3. And the center is the 0, and that's the upper half. If I look at the other side, the red one, now see the domain is now from -3 to +3. The range is now from -3 to 0. I have again a radius of 3 because that distance is 3, that distance is 3, and that distance there is 3. So my range start at the lowest value, which is -3 in this case, and the semicircle is the lower half of a circle with center or the origin. On this page I've shown how to get to these two formulas. So we will start with my original shifted formula. My y is implicitly defined here, but I want now the explicit definitions for y, and to do that I must first isolate this term y minus k square, because my purpose is to isolate y, but I can't do it directly. I must start with y minus k squared. So I take everything else to the right hand side. So then to get rid of the square root, I draw square root both sides, but remember I must have the plus or minus. So then I get y minus k is equal to plus or minus that. I just simplify it, and then I take that minus k, I add plus k both sides. So I add a plus k here and I add a plus k there. So that gives me my final equation. That's why there's no extra sign here with the k. There's not a plus or minus at the k. It's just with the square root. So if I now have my h, which is with the x, if my h is negative, then the graph will shift to the left. It's just the same as the parabola, the hyperbola, the exponential functions, etc. And if the h is positive, remember that's to do with the x's. If the h is positive, then the graph will shift to the right. If the k is negative, then I'm subtracting from the y, so I'm shifting down. If the k is plus, I'm adding to the y, so the graph will shift up. So this is just a reminder of the theory. You must be able to do this on your own. Here's a simple example of upper half. First of all, the green graph, which in this case I use as my mother graph, is 9 minus x squared. I have a radius of 3. I have the center as the origin. And then I have this simple formula, and where my, again, this is a plus, which I don't write, and it's a square root. I don't write it 2. I don't write square root of 2 like the cube root. I just write square root sign. Okay, so that is that. So the red graph then is this equation. Okay, what happens here is if I take my origin here, then to get to the center of this red graph, which is now the point 2, 0, then I had to move 2 units from -3 to -1 is 2 units. From 0 to 2 is 2 units. I've moved 2 units to the right, and that's why I have this formula 9 for the 3 square minus x minus 2. The h is 2, it's positive, so I've moved to the right. So my domain, my x minus 2, is in between 3 and minus 3. So my x will be in between 5 and minus 1, which is in accordance to what we see on the graph. So in the end, I can write my domain as minus 1 to 5. There's no open dots here, so I can just assume that the endpoints is included. My range is from 0 to 3. As for the green graph, my center is now the point 2, 0, and my radius is equal to, is exactly the same as the green graph, and that will be 5 minus 1 divided by 2, that is 6 divided by 2, which is equal to 3. So the red graph is the green graph shifted 2 units to the right. Let us find this domain algebraically. So let us look at this 9 minus x minus 2. If I did not go that route, let us see. Now, what's inside the square root must be greater or equal to 0. So I will have 3 minus x minus 2 times 3 plus x minus 2 greater or equal to 0. So I can write it as minus x, and then I get 3 plus 2, that gives me 5. And I can have x plus 1 greater or equal to 1. So this is a parabola that's concave down, and it will have values of minus 1 and 5. So, and greater or equal to is there, so x is less than or equal to 5, greater or equal to minus 1. So if I solve it algebraically. Remember, it's again what we call the K method, where we let this x minus 2 equal to something. So we had 9 minus k squared greater or equal to 0. So get 3 minus k times 3 plus k greater or equal to 0. And then we solve it with a parabola. Again, let us look at the green graph. This is again 9 minus x squared, square root of that. So this is 1 in the standard form. The origin is the center, and the radius is equal to, not to 2, is equal to 3. So our blue graph is exactly the same as our green graph, but in this case we can see that there is a difference of 1. There's a difference of 1. So it shifted 1 unit to the left. Green graph shifted 1 unit to the left. It did not shift up or down, so that's why we have that equation there. And why is it to the left? Because this x plus 1 is the same as x minus 1. Remember, it must be in the form x minus h. X minus h is equal to that. So h is equal to minus 1. So what is the domain? And that we can find from here, which is now from minus 4 to 2. Or we can say x plus 1 is less than or equal to 3, greater or equal to minus 3. So x will be less than or equal to 2 and greater or equal to minus 4, which coincide or correspond to our graph here. So this is algebraically, and this is read from the graph. So the range is again just from 0 to 3. The center is now also shifted where it was, the origin. Now it shifted 1 unit to the left, so it should be 1, 0. We can see here is the center, because that distance there is 3, that distance there is 3, and this distance there is 3. Our radius is equal to 3, and then we said what happened, it was just shifted. So let us look at the next example. This is now my orange graph, and I now said that this is the equation, and you have to be able to write it down on your own. So what's happening here? We see that in this case the orange graph is much bigger than the green graph, but how much bigger? Let us first look at the domain. If I look at the domain, I see that it's from -3 to 9. That is from the graph. And the range is everything. If I look at the top value there, I see that is 6. If I first look at the radius, I see it is 9 minus 3 divided by 2. That is 12 over 2, which is equal to 6. And that corresponds to this 36 there, which is 6 squared. To get the domain, we can say x minus 3 is less than or equal to 6, greater or equal to minus 6. So x is greater or equal to minus 3 and less than or equal to 9. So this also corresponds to the graph here. And it corresponds to what we wrote there. So the range is everything from 0, because it did not shift vertically, and then we just add the radius, which is 6, so it's from 0 to 6, that distance there. So the midpoint will be 3, 0. So the center will be 3, 0. That's the center, and we see it from the graph. And the orange graph, hx, is the green graph f of x stretched vertically with a factor of 2. And we get that from the 6. 6 is equal to 3 times 2. So what we had before was a radius of 3. Now we have a radius of 6. So it's double what we have. And then shifted 3 units to the right, because my h is equal to 3 is positive. So I've shifted 3 units to the right. So here I explained why is the graph stretched by a factor of 2 and not 4. Because 36 is that, it's 2 times what we had before.